Imagine an explosion so massive it created everything. But what if it wasn't an explosion at all? Welcome to our exploration of the Big Bang Theory. So what is the Big Bang Theory? Well, let's start with the basics. The Big Bang Theory is a cosmological model, a story, if you will, about the birth of our universe. It's a tale that begins around 13.8 billion years ago. Imagine, if you can, all the matter, all the energy, everything that makes up galaxies, stars, planets, you, me, and even the space itself, concentrated at a single point. A point so dense, so hot, it defies our understanding of physics. Now picture this point beginning to expand. Not an explosion as we often imagine, but an expansion, a stretching of space. The universe wasn't born in a fiery blast within the void, rather, the universe itself expanded, and it's still expanding today. The galaxies are not rushing away from a central point, but space itself is growing between them. As the universe expanded and cooled, energy transformed into particles of matter and antimatter, which annihilated each other upon contact, leaving behind photons or particles of light. Eventually, the universe cooled enough for atoms to form, which later coalesced to create stars and galaxies. And here we are, billions of years later, a part of this ever-expanding cosmic tapestry. But isn't the Big Bang just a theory? Yes, it is. In science, a theory isn't a wild guess or a hypothetical idea, but a well-substantiated explanation of some aspect of the natural world. The Big Bang Theory is supported by a wealth of scientific evidence, from the cosmic microwave background radiation to the large-scale structure of the universe. So that's the Big Bang in a nutshell, but let's dive deeper and debunk some myths surrounding this theory. Now, you might have heard some things about the Big Bang that aren't quite accurate, so let's set the record straight. First myth: the Big Bang was a massive explosion. This is a classic misunderstanding. The term Big Bang might suggest a colossal detonation, but it's not an explosion in the traditional sense. Rather, it's about the rapid expansion of the universe from an extremely dense and hot state. This expansion is still happening today, and it's not an explosion originating from a single point, but an event that occurred everywhere in the universe simultaneously. Next, the Big Bang happened at a specific location in space. Again, this is a misconception. It's easy to picture a bang happening somewhere and then spreading outwards, but that's not how it works. The Big Bang didn't originate at a single point within an existing universe. It was the birth of space and time itself, the start of the universe. This means the Big Bang happened everywhere. Every point in the universe today is a point where the Big Bang happened. Finally, the Big Bang theory contradicts the existence of God. This myth stems from a misunderstanding of what scientific theories do. The Big Bang theory doesn't concern itself with why the universe began or what caused it. It simply describes what happened based on observable evidence. It's a common misconception that the Big Bang theory and religious beliefs are inherently contradictory. However, many religious individuals and scientists alike do not see a conflict between faith and accepting the Big Bang theory. It's crucial to understand that science explains the how, while religion often seeks to explain the why. To put it simply, the Big Bang theory is about the development of the universe, not about its ultimate origin or purpose. So while the theory can coexist with religious beliefs, it doesn't offer a theological argument. Clearing up these misconceptions helps us understand the Big Bang theory more accurately. It's not about a massive explosion in a specific location that challenges the existence of God. Instead, it's a theory explaining the observable expansion of the universe from a hot, dense state. It's a testament to human curiosity and our quest to understand the cosmos. Remember, science is a journey of discovery, and along the way, we might encounter myths and misconceptions. But by delving deeper into the science behind these theories, we can separate fact from fiction and appreciate the fascinating reality of our universe. With those myths debunked, it's time to explore some actual scientifically backed facts about the Big Bang theory. Ready for some mind-blowing facts about the Big Bang? Brace yourself. The Big Bang theory is our best explanation for how the universe began. It's not about a massive explosion that happened in one place, but rather an event that occurred everywhere at once, about 13.8 billion years ago. The universe we know and love, with all its galaxies, stars, and planets, emerged from an extremely hot, dense state, smaller than a single atom. Now, let's delve into the evidence that supports this theory. First on our list is the cosmic microwave background, or CMB. This is the afterglow of the Big Bang, a faint whisper of radiation that permeates the entire universe. The CMB is a snapshot of the universe at a tender age of about 380,000 years. It was first detected unintentionally by Arno Penzias and Robert Wilson in 1965, and its existence is a strong testament to the Big Bang theory. Our next piece of evidence is the redshift of galaxies. When we observe distant galaxies, we notice something peculiar. The light emitted by these galaxies is shifted towards the red end of the spectrum. This redshift happens because the galaxies are moving away from us, and the light waves are stretched, making the light appear more red. This implies that the universe is expanding, and if we were to rewind this expansion, everything would converge to a single point, the Big Bang. Finally, let's discuss the abundance of light elements. In the early universe, conditions were just right for the formation of light elements like hydrogen, helium, and traces of lithium. The Big Bang theory predicts the ratios of these elements accurately. When we look out into the universe today, we find that the observed ratios of these elements match the predictions remarkably well. So, what do these facts tell us about the Big Bang theory? Well, they show that this isn't just a fanciful idea thought up by scientists on a coffee break. It's a robust theory, built on solid observational evidence. The cosmic microwave background radiation, the redshift of galaxies, and the abundance of light elements all point towards the same conclusion, that our universe began from an incredibly hot, dense state around 13.8 billion years ago. These are just a few facts that support the Big Bang theory. But what does all this mean for our understanding of the universe? So, we've traversed the universe, debunked myths, and uncovered facts. But what's the big picture? Let's take a step back and gaze at the mesmerizing mosaic we've pieced together. It's a tapestry woven with threads of scientific inquiry on the loom of the cosmos. It all starts with the Big Bang theory, the cornerstone of modern cosmology, which proposes that our universe began as an incredibly hot, dense point nearly 14 billion years ago. From there, it has expanded and cooled, evolving into the vast cosmic expanse we observe today. We've debunked the myth that it was an explosion, clarifying instead that it was an expansion of space itself. We've also dispelled the notion that it provides an explanation for the origin of everything. In reality, it explains the development of the universe from a tiny fraction of a second after its inception. But the Big Bang theory is more than just a story of cosmic origins. It's a testament to the power of human curiosity and the scientific method. It's a narrative that challenges us to look beyond our immediate surroundings, to question and explore the fundamental nature of the universe. This understanding of the Big Bang theory and its implications is not just for scientists, it's for all of us. Because it's not just about distant stars and galaxies. It's about our place in the cosmos, our shared cosmic heritage. It's a story that connects us all, from the atoms in our bodies to the furthest reaches of the universe. Understanding the Big Bang theory elevates our perspective, enabling us to appreciate the grandeur of the cosmos and our intricate connection to it. It underscores the importance of scientific literacy in a world increasingly reliant on technology and science. There you have it, a journey from the beginning of time to the present, all thanks to the Big Bang theory. Stay curious and keep exploring the wonders of our universe. Until next time.